In this lecture, we're going to move one step closer to our modeling of the 3D shaped object we have here. We're going to add constructors to our class and provide ways to initialize the member variables inside our class, and you're going to see different ways to do that. So let's head to Qt Creator and get this going. Okay, here we are in Qt Creator, and the first thing I want to do is to copy this entire code from the last lecture, because we're going to need it. Create a new project. Call it 1.10.2 and save it in the usual location. Next, until we have the project here. We're going to get rid of all this and put in the project as we had it in the last lecture. I want to do it this way because I want you to have the source code for the previous lecture if you happen to need it. And we have our project. Let's run it. It should print 200 as the area of the rectangle that we have. And boom, 200 here. The first thing we want to do is to provide a constructor for our class here. If you look in the main function, what we did, we defined the rectangle and we had to specifically set the width. Using constructors, you can initialize your classes and give them initial values for the member variables without calling the setters explicitly like this. And we're going to do that. But before we do that, I want to show you what a default constructor is. To define a default constructor, you come here in the public scope of your class, and you define it simply by saying the name of the class and putting parentheses like this. You don't put a return value or anything, you just put it like this. And we're going to define it outside the class so that we give it a body to work with. So we're going to say rectangle, like we did for the other methods. And we're going to initialize the length and the width to 5. Let's do it this way for now. Okay, now that we have the default constructor, we should put a log statement here saying that the default constructor was called. And we're going to get rid of these setters because we don't need them anymore. So just doing this is going to call the default constructor that we just defined. If you don't believe me, we're going to run the application and we should have an area of 25 because the default constructor sets these values to 5 and 5. And we're going to see this statement. Let's run the application. Boom, default constructor called, and the area of the rectangle is 25. So now you know how to use a default constructor. It is the name of the class with the parentheses like this, and you can do whatever kind of initialization you need to do inside here in the body of the default constructor. On top of the default constructor, you can also have other kinds of constructors. So we're going to define another one. And in this one, we're going to pass our explicit width and length. Okay. So we're going to go down here and define it. Remember, a constructor doesn't have a return value. And we're going to say this width equals W that we pass in here, and this length equals the length that we pass in the parameter. And how do you call this? You call it in the main function by saying something like rectangle R1 and giving the parameters that you want to pass in here. And let's say 2020, just to make the calculations easy. And we're going to compute the area for R1 instead of simply R, which was calling the default constructor. And we should put a log statement inside here so that we know what is happening. let's say custom constructor called. And what do you think we'll see when we run this application? What is going to be the area? Okay, let's run and see if that you guessed it. 400, and it is the area of the second rectangle that we defined here. You see that the width is 20, the length is 20, and the area should be 400. So this is how you define your own constructor for your classes that you define. And the constructors are really important if you want to initialize your own types. Okay, now you know about default constructors, you know about your custom constructors that you can define, and you know this notation, you know that you can define them inside here, you know that you can define them outside here using this notation. But there is another notation I want you to know, which is the initializer list. You're going to see it in every place, and I want you to at least recognize it when you say it. The way initializer lists work, you pass the initialization code to initialize your member variables just after the parameter list on your constructor. And I'm going to show you how it works right now. Okay, right now we have this notation. So for you to keep it, I'm going to comment it out right now. Okay. And I'm going to copy it and modify it to use initializer lists. So the way this works, we get rid of our initialization here because we don't want to do it there. We put a colon here and we say width we pass in the parameter inside the parameter list, and we say length and we pass in L. And just like this, you initialize your values inside the constructor. If you run the application, it shouldn't have any problem. It should work as it worked before, but notice that we are using an initializer list notation here to initialize our member variables. So let's run it. 400, the area of our rectangle, no problem. It works as it was working before, and it's all fine. Okay, now that we know about initializer lists, we should try and model the 3D shape here. The class that we're going to use is going to have two member variables. One is going to be the base rectangle here, and the other is going to be the height. That is going to allow us to know how high it is, and it's going to allow us to be able to compute the volume of this thing here. So let's head to Qt Creator and do that. Okay, here we are in Qt Creator, and our class is going to be called Para. So let's get rid of this. We're going to say class Para, as we usually do. Para is going to have two private member variables. One is going to be the rectangle object, and the other is going to be the height. Okay, and we should define our constructor right now. The constructor is going to be Para. It's going to have a width, it's going to have a length, it's going to have a height too. And now we need to find a way to initialize our things inside the constructor. Remember our class has a member variable that is a rectangle, and we have no way to directly initialize the rectangle, but use initializer list, and that's why they're very important. And this is a way that the C++ programming language gives you to initialize custom classes that you have inside your class. So we're going to put a colon here and pass in the width and the length to initialize our rectangle here. We're also going to initialize the height. Okay, we're going to say height h. Okay, after we do this, we're going to define our body. And in the body, we're going to say para constructor called. Okay. And like this, we should really be fine in creating our para class. The next thing we want to do is to provide a method that computes the volume of our 3D shape here. And the method is going to say get volume, and it's going to return the area multiplied by the height. Okay, and this should give us our volume that we want. So we go in the main function, we initialize our para, and we give it a width. Let's give it 30, 30, 30 so that we see that it has an area of 9,000. So let's do that. 30, 30, 30, like this. So we should output a message here to say cout. The volume of our shape is P get volume. Okay, so we run the application, and if we're lucky, it's going to work. Okay, you see that we get this error here. It is saying that the constructor of Parror is private. And what did we forget? We forgot to make this public by putting a public keyword here. Okay, if you don't put it, it's going to be private by default. If you didn't know that, now you know. So let's run the application again. Okay, it's running here, and you see that we have a volume of 27,000, which is 30 times 30 times 30. This is okay. Okay, by now you really have a class that can model your thing, our 3D shape, and it is using two classes. One is the rectangle, and the other is the para class that we just defined here. This is a good basis for you to model your own objects and use your own objects inside other classes that you have created. By now, we've covered or we set out to do in this lecture. In the next one, we're going to look at subclassing your classes and how you can split your code into different files to have things more organized. I'll see you in the next lecture.